Hello everybody. Today we're going to look at graphing of functions with a graphing calculator. Turn on your calculator and follow along with me. Suppose we have the line that we would like to graph being f of x equals 3/2 x minus 8. We could put this into our y equals and get a graph as follows. First of all, you have to push the y equals, and then 3/2, which is 3 divided by 2, x minus 8. Put that into our graphing calculator. Now, the thing that's different about graphing a line or a function as opposed to creating a scatter plot is it's easy to put in the data for graphing a line. You just put it in the y equals. But for finding a window, this can sometimes be tricky. There are a few guidelines. For example, this particular equation, you know it is a line. It's in slope-intercept form. So you know that it's going to cross at -8 on the y-axis. And then it's going to have a rise of 3 and a run of 2. This helps us in deciding what window to pick. Crossing at -8, a good window might be what's known as a standard window, meaning just like here it says over here in this window, x min being -10, x max being 10, so forth. If this window isn't in your calculator right now, which I believe it's in mine, but if you want to get to it very quickly, you can push zoom and then 6 for zoom standard, and there you have it. You have the graph of that line. Okay. This is done with a majority of the lines that you see, very common algebra lines, can be done in this what's known as a standard window. It's a very nice tool to have. However, not all lines can. Let's consider this next equation right here. This equation, y equals 3,249 minus 87x, where y is the balance you owe your parents and so forth from this particular situation. Let's just consider the example of y equals. Again, you go to your y equals, clear out this line, and we'll put 3,249 minus 87x, and what you'll see is when we push graph in this window, we don't see anything. Well, that's because way up above somewhere here is where the y-intercept is, and the slope doesn't bring it down fast enough for us to see it in this particular window. So we have to pick a window that will work, and that takes a little bit of practice. It's not terribly hard, just takes a little bit of practice. This is for particularly big numbers. Let's take a look. The y-intercept to this equation right here is 3,249. This is the number that doesn't have an x by it, so this is, we know, is the y-intercept. So we should make our y max somewhere bigger than that. We'll go down. Somewhere bigger than that. Let's say 35 would be a good idea. So 3,500. And I'm going to leave the y min as -10. And here's why I'm going to do that. Not that I'm hoping to see anything down there, but on my graph, on my calculator, I'd love to be able to see a axis. So it looks nicer that way. So I'll leave that. Now here's another problem. The y scale goes from in jumps of 1, which would mean if you looked at this graph, if it had jumps of 1 on this y-axis, it's going to go have, looks like 3,510 dots that would start at the bottom of your screen here and go to the top of your screen. So basically it would look like a solid line. That many dots, the pixels aren't that good on these calculators. So well, you need to change that into some reasonable amount. Even if we used 100, well, then we'd have 35 dots that went from top to bottom. So that's probably not as good. My next choice might be 200 or 300. I think a nice even one to choose is 500. 500 is a scale. We'll go 500, 1,000, 1,500, 2,000, so forth. And there's not that many dots. So that's good. Now let's push graph and see what we get. Okay, we see the line, but you can see it just sort of chops the very tip off here. There's probably a lot more information that goes on past 10. And it looks like this is a big blank area over here. We don't really need all of that. So the line interesting spots are going to be the y-intercept and possibly where it crosses the x-axis. That's another spot of interest. So for a line, what we would like to do is change this window, and let's make we'll leave the min that. Well, no, we'll change the min to -1, and we'll change the max instead of to 10. Let's change it to 40. And again, we want to change it to something other than by ones, and in this case, by 5 seems to give us a reasonable number of dots. Now when I push graph, now I have a graph where I can see the y-axis and I can approximate where the x would cross. This is a very good graph for this particular situation using very large numbers. Now suppose we have an equation that looks at very, very, very small numbers. At first with this one you might be tempted to try to figure it out using this scale. I like to go from the fact that this y-intercept is within a standard window. I could just push zoom 6 and see what I got. And this obviously doesn't look very good, but you can see just by these two little lines that popped up that it's somewhere in that standard window. Now using that y-intercept, knowing that the y-intercept is there, I might go ahead and make my window range for this, for y, a little different. I might make it smaller, make this -0.01, and make it square, so make this top is the same as the bottom. I'll change this to 0.01 and have this go in jumps of 0.001. Meaning that what I'll get is eventually within this range now, this number shows up, -0.004, will show up in that as I work my way down. And to see what the graph looks like for that, okay, now I have the opposite problem. This is this going from -10 to +10 on this side is too big. So I'll go back up to this and I'll make this one smaller. How about I make it the same as this just to see what it does? -0.01 and 0.01 and 0.001. And I push graph. My line's looking better, I will admit, but it looks a little too much like a horizontal line, and by the fact that it's sloping up a little bit, I feel like somewhere way out here it's going to cross the x-axis, and that's important information that I want to have on my graph. We'll use it quite a bit in this class. So what I'd like to do is go back and maybe make this x scale a little bigger. Not a lot bigger, a little bigger. To make it a little bigger, maybe I'll take out these zeros here, make it go from 0.1 to 0.1, positive to negative. And that would mean I want to change the scale. I want to take a 0 out of the scale as well. And let's see what that looks like. Oh, that's quite nice. So this would be a very nice graph for something that has very, very small numbers. And again, you have numbers that have equations that have very, very large numbers. And then you have very typical equations that are more likely what you see on a daily basis. All those can be accommodated by the graphing calculator. The trick is picking the right window.